Reviewing lessons 2.5 through 2.9, if you look on page 147, we'll look at some vocabulary that we've talked about in these lessons. So number 1, change in y divided by the change in x. That would be the slope of a line. Number 2, the point on the graph where the line crosses the y-axis is the y-intercept of a line. Number 3, the slope-intercept form of a line is y equals mx plus b. Variable m in the equation stands for the slope, and the variable b in the equation stands for the y-intercept. Lesson 2.5 is on comparing proportional relationships. If you look at the example off to the side here, a graph shows the rate at which Rob jogs. Emily's jogging rate is represented by the equation y equals 8x, where x is the number of miles and y is the number of minutes. At these rates, he will finish an 8-mile race first. So what they're doing, one of these is the graph here is for Rob, and then they have an equation for Emily. Basically what we could do is figure out what their rate is by the graph and by the equation. So by the graph, it is proportional since it goes through 0, 0. So you could technically look at it right here. You could say in 1 mile, Rob went he went 1 mile in 6 minutes. Emily, we know that that coefficient in front of x is our slope, which is like the rate of change. So Emily's going 8. She goes 1 mile in 8 minutes. 8 minutes per mile. Yeah, 8 minutes per mile. Rob is actually 6 minutes per mile. This is kind of confusing because we're used to it probably as miles per minute instead of minutes per mile. So actually, by this, if Emily, it takes 8 minutes for a mile, and Rob is 6 minutes for a mile, then Rob is actually a quicker runner. Okay, so that's kind of backwards. Like I said, normally the time is the x-axis, so they put it backwards for some reason. Our question over here, number 1, this is a little bit better because we've got the time as the x-axis. 2 trains are traveling at a constant rate. Find the rate of each train and which train is traveling at the faster rate. So look at train A. So for train A, looking at the table, might be tempted just to go ahead and say, let's take the miles divided by the hours, so like 50 divided by 2 is 25, and then you might say, well, I'm done. Really should check some of these other points and make sure they all come out the same. The only way we can do the y divided by x is if it's proportional. If it's not proportional, what always works is change in y divided by change in x is your slope. So what would for sure work, besides dividing all of them out and make sure they all equal 25, would be look at your y values here. We went from 50 to 75. So if you subtract those, that's a difference of 25. X's, we went from 2 to 3. So if you subtract those, that's a difference of 1. And 25 divided by 1 is 25. So that does confirm this actually is proportional. So it would work the other way. But again, if you choose to just divide those out, you need to double check it. Don't just do one of them and move on. because if it's not proportional, you'll not get the correct unit rate for that. Okay, so train A is going 25 miles per hour, and then we can look at the graph here for train B. So for this graph for train B, it actually is proportional. It goes through 0, 0. It's a straight line. So you could technically just look at, after 1 hour, where are we at? And you can see 1 hour we're at 20 miles, so that means 20 miles per hour. The other thing that always works, again, even if it's not proportional, is change in y over change in x. So change in y is 20, change in x is 1. So 20 divided by 1 would be 20 miles per hour. So the question then was which train is traveling at a faster rate? So faster rate then would be train A. Okay, and again, you would want to say, make a complete statement there. Train A is faster, train A is going 5 miles per hour faster than train B, something to that effect. Number 2, a 16-ounce bottle of water from store A costs $1.28. The cost in dollars Y of a bottle of water from store B is represented by the equation y equals 7/100 x, where x is the number of ounces. What is the cost per ounce of water at each store? And which store's bottle of water costs less per ounce? So we want to find the cost per ounce. So for store A, cost per ounce, we just need to divide the cost by the number of ounces. So $1.28 divided by 16 is 8/100, which means 8 cents per ounce. Store B, if you look at the equation is telling you the cost per ounce. That's the rate of change, which is the slope of the line. So that's store B by the equation. We know that that is 7 cents per ounce. So based off of that, then we could say that store B's bottle of water costs less per ounce. Lesson 6, connect proportional relationships and slope. So this is where we first started talking about slope. So slope, it says if it's in a proportional relationship, slope is the same as the unit rate and the constant of proportionality. So remember we talked about like y equals kx, y equals mx then. So here graph shows the number of miles a person walked at a constant speed, find the slope of the line. We've been doing that quite a bit. You guys are getting pretty good with that. So again, slope is the change in y divided by change in x. So just pick 2 points and then figure out what your slope is. So the points that the book chose here, they chose 230 and 460. Okay, and those are really the only 2 points that hit nicely on this problem. So really don't have a whole lot of options there. Okay, and again, basically looking at change in y, change in x. So we went up 30 and we went over 2. 30 divided by 2, which is 15, is our slope. So same idea if you look at the practice problem here. Graph shows the proportions of blue paint and yellow paint that Brianna mixes to make green paint. What is the slope of the line? And tell what it means in the problem situation. So first let's just find what the slope is. So in order to find the slope, we need to find 2 points the line goes through. The point 0, 0 is on our line, and so is the point 65. Be careful, there's some that are pretty close. It almost looks like 5, 4, but it's actually just above that point. Anyway, so these would be 2 points on our line. Then we could find our slope. Remember, slope's a change in y over change in x. So to find our change in the y, we're looking at our y values. So y values, we could do 5 minus 0. X values going in the same order, we could do 6 minus 0. 5 minus 0 is 5, 6 minus 0 is 6, and so our slope would be 5/6. And then the question is also, what does it mean in the problem situation? So one way of looking at this, you could say that we need a proportion of 5 parts yellow paint to 6 parts blue paint in order to make this shade of green paint. They didn't tell us what we're talking about. If we're doing a large amount, maybe we're talking about gallons of paint. So another option, another thought for you guys might be, 5 gallons of yellow paint, 6 gallons of blue paint we could combine to make this shade of green paint. Lesson 7, analyze linear equations, y equals mx. So talked about proportional relationships, y equals mx, m is the slope. So here on the example, they want us to graph this line. So looking at the line, this is in this form, y equals mx, m is our slope. Basically means our slope is 2. And remember, this is in that also y equals kx format, so we know it's proportional. Nothing's being added or subtracted. So it is going to go through 0, 0. The slope's going to be 2. Slope of 2 is like 2 over 1. So from 0, 0, we could go up 2 and over 1 and get to another point on the graph. So if we look at the practice, right before that's kind of our directions here. A mixture of nuts contains 1 cup of walnuts for every 3 cups of peanuts. And they want us to write a linear equation that represents the relationship between peanuts x and walnuts y. Make sure you're keeping track of this. I've got it color coded here. You're welcome to use color pencil to keep track of your stuff better if you want to. Okay. So we're going to assume this is proportional. If it's proportional, basically we could just put our y over x. So y is the walnuts. We have 1 cup of walnuts. X is the peanuts. We have 3 cups of peanuts. So basically we're going up 1 and over 3. So our slope is 1/3. So our equation would be y equals 1/3 x. Another way of doing this, you guys could make a table and you could say, well, if we start out we don't have anything, and then we can go and say we have peanuts as the x, so 3 cups of peanuts, 1 cup of walnuts. We can go to the 0.31, and then you could actually graph those if you want, and then say I go up 1 and over 3, and then that gives me that slope. Then that gives me my equation. And then part 2, they actually want us to graph the line. And again, if you guys wanted to, you could graph the line and then go back and do the equation. Okay, it doesn't matter what order you necessarily work this out in. We know it's going through 0, 0, and then like I said, 1 cup of walnuts, 3 cups of peanuts takes us to the 0.31 over here. And then we can just draw a straight line through that, put an arrow on the end, and we've got our line. Lesson 8 is where we first talked about y-intercept. So y-intercept is where the line crosses the y-axis. So on the graph here on their example, it's crossing the y-axis where our y value is 0, so our y-intercept is 0. It's crossing through 0, 0. On the y-intercept, the x is always going to be 0. The question is, what's our y value? So over on the practice, we have this equation that represents the cost of getting a car wash and using the vacuum for X minutes. This is kind of backwards from what we're used to seeing. Remember, normally we have y equals mx plus b. So if you wanted to, you could switch this around. Y equals 5/10 x plus 5. That's how we're used to seeing the equation written in that slope-intercept form. So the first question, what is the y-intercept? So y-intercept is 5. That's where our graph's intersecting the y-axis. So y-intercept is 5. And then what does the y-intercept represent? Think about the coordinates of this point. The coordinates of this point are 0, 5. So that represents 0 minutes. It's going to cost us $5. So this is like an initial cost that we have. Actually, it's talking about cost of getting a car wash and using the vacuum for X minutes. Basically represents then, we could just say is that the cost of the car wash is $5. Okay, we got the car wash, and then after that, then we're using the vacuum, and the vacuum is the additional charge for us here. Okay, you could say 0 minutes vacuuming costs $5, and again, that goes back to though that we got a car wash first. Lesson 9, analyze the linear equations y equals mx plus b. So again, this is slope-intercept form. So the example, they want us to write the equation of the line. Equation of the line, we need two things. We need the slope and the y-intercept. So y-intercept's -3. Find another point. We could go up 2 and over 1. So 2 over 1 is the same as 2. Slope is 2. So the equation would be y equals 2x minus 3. Or you could say y equals 2x plus -3 would be the same thing. So if you look at the practice, they've given you an equation and they want you to graph the line. First thing, before you do that, you may want to add the opposite here. So from our equation, remember the equation here, it's like y equals mx plus b. M is our slope, b is our y-intercept. We know -1 is our y-intercept, so we could graph that point. So then we can look, our slope is 1/2. Remember, slope, it's change in y over change in x. So from that point, we can go up 1 and over 2, and that'll get us to another point on the graph, which would be at the point actually 2, 0. And then we draw a line through that. Always think about once you've graphed your equation, is my line going the correct direction, whether we have a positive or a negative slope. Number 2 is kind of backwards. This time they've given us the graph and they're asking what the equation is. So in order to come up with the equation, 2 components we need, the slope and we need the y-intercept. Easiest one to just look at would be the y-intercept. So y-intercept is 3. And then the question is, what is our slope? So find another point besides your y-intercept. We can see we're going down 1 and over 1. So change in y over change in x, -1 over 1, which is -1. So equation is y equals -1x plus 3. Technically, if you had just y equals -x plus 3, that would be okay, but it doesn't hurt anything to put the 1 there as well. So this gives you a little bit of a review on lessons 2.5 through 2.9. As always, you'll want to go back and look through your books and make sure that you have covered all of the different material that has been presented to you in these lessons.